Good morning, students. In today's lecture, we will discuss about active methylene compounds. This particular topic is taught to undergraduate program students in their sixth semester as per Delhi University syllabus. Under this head, we will discuss what are active methylene compounds, why these compounds are called active compounds, and examples of some active methylene compounds, and we will also discuss Claisen condensation and in detail, and we will prepare ethyl acetoacetate using this method. Now first is what are active methylene compounds. So by definition, active methylene compounds are the class of compounds in which the CH2 group is attached to two electron withdrawing groups. Now these electron group withdrawing groups, what do? They withdraw electron from CH2 group, and due to this methylene group becomes acidic in nature, and this is how these compounds are synthetically very important, because this property of these compound paves the way for the synthesis of library of different compounds. So here are some examples of active methylene compounds. We can see in ethyl acetoacetate, the CH2 group or methylene group is attached to two electron withdrawing group. This is ethyl acetoacetate, where methylene group is attached to two electron withdrawing group, whereas this is diethyl malonate, again CH2 group is attached to two electron withdrawing group. So the acidic behavior of these compounds of the CH2 group can be shown or can be represented by pKa values of CH2 protons. Now question is, and which is very favorite question of examiners, they usually ask this question: why is methylene group in ethyl acetoacetate active or acidic? So how the answer to this question is to be written? So this is due to two effects. First is inductive effect and second is resonance effect. As we have already discussed that due to inductive minus I effect of these two electron withdrawing group, these two CH bonds, this CH bond and this CH bond become weak, and due to this entire CH2 group behaves as acidic group. Another effect is resonance effect. So here we can see, in presence of a base, if this proton is removed, which is supposed to be an acidic proton, if it is removed and if it is acidic in nature, its conjugate base should be stabilized. So we can see, if we remove this proton by means of a base, the conjugate base that is formed in this reaction or carb anion gets resonance stabilized. So negative charge which comes on this carbon gets delocalized in this CO bond. So we can see, due to this resonance, the resulting carb anion is getting stabilized. So that is why methylene group is in ethyl acetoacetate is said to be active or acidic. Now what is Claisen condensation and how can we prepare ethyl acetoacetate using Claisen condensation? So Claisen condensation is basically self-condensation of an ester molecule in presence of base to give active methylene compounds. So if we take ethyl acetoacetate as a representative compound, the reactant of ester which is to be taken is ethyl ester. So two molecules of ethyl ester in presence of sodium ethoxide, they are forming ethyl acetoacetate, and here you can see a slight amount of H plus ion which are coming from HCl or acetic acid is also there. So we will discuss the role of acid and role of base in this reaction. This is the mechanism of this reaction. Reaction goes through in 3 different steps. In step number 1, we can see this ethoxide ion, which is coming from a strong base, which acts as a strong base. It abstracts a proton from ester molecule, leading to the formation of enolate ion. And here we can see this enolate ion is getting stabilized via resonance. Second step, what happens? This enolate ion behaves as a nucleophile, and this nucleophile attacks on carbonyl carbon of the second molecule of ester to give an adduct. So it is a simple nucleophilic addition reaction to give this adduct. In third step, what happens? There is removal of alkoxy ion or ethoxide ion, which has to be regenerated because in first step we are using ethoxide ion to start this reaction. So here, as soon as this molecule loses an ethoxide ion, it will form an ethyl acetoacetate molecule. Now the question is, why is acid added in this reaction, or what is the role of HCl or acetic acid during Claisen condensation? Now what happens? The whole reaction is taking place in presence of a base, and this base is very strong base. So once when ethyl acetoacetate is formed in reaction mixture, and there is some amount of base which is left in reaction mixture, what will happen? What may happen? This base may abstract a proton from here and it will form a carb anion. So in order to convert this carb anion into ethyl acetoacetate, acid is added. So this is how this reaction goes. Now next topic is keto-enol tautomerism. So aldehyde and ketones, as we all know, they undergo this particular type of tautomerism, which is known as keto-enol tautomerism. So this is the keto form and this is enol form. This en is here and all is here. So this is keto-enol form. So here are some practice questions for you. So you need to write keto-enol tautomers of acetone and acetaldehyde, and you have to differentiate between tautomerism and resonance, taking suitable examples. We will discuss these questions in our next lecture. So another question which is important is to explain keto-enol tautomerism in active methylene compound. So we can see, like aldehydes and ketones, active methylene compounds also show keto-enol tautomerism, where hydrogen of active methylene group migrates from here to the oxygen of carbonyl group. So this is how this migration takes place. Okay, and here, because this H group is in vicinity to this electronegative group, so there is formation of hydrogen bond, which gives stabilization of this particular form, provided that the size of this ring or chelation is large enough to give stability to this compound. So this is keto form of ethyl acetoacetate and this is enol form of ethyl acetoacetate. So this chelation is supported by this ring formation, and this ring formation contains 1, 2, 3, 4, 5, 6 involvement of 6 atoms in it. Another question is, you need to write keto-enol tautomer of diethyl malonate. Now think about it. Why is enol form of ethyl acetoacetate is more stable than enol form of acetone? As we were discussing aldehydes and ketones, they also show keto-enol tautomerism like active methylene compounds. So if we compare the stabilities of enol forms of acetone and enol form of ethyl acetoacetate, we see that enol form of ethyl acetoacetate is more stable as compared to enol form of acetone. Why? This is because This is the enol form of acetone. We can't see any stabilization in this molecule after enolation, whereas enol form of ethyl acetoacetate is getting stabilized through this chelation, and this chelation contains 6 atoms. Okay, so this hydrogen bond, and this hydrogen bond is intramolecular hydrogen bond, which is present in case of ethyl acetoacetate and it is not present in case of acetone. So due to this intramolecular hydrogen bonding, enol form of ethyl acetoacetate is chelated, and this chelation stabilizes this particular form. This is why enol form of ethyl acetoacetate is more stable as compared to the enol form of acetone. So this is all about today's lecture and today's topic. In our next class, we will be discussing about synthetic importance of active methylene compounds. Thank you.